Hi, this is Mrs. Vrobel. This is part 3 of chemical reactions. So for the first video, we looked at how to write a chemical equation, how to balance it. The second one, we looked at how to identify the types of chemical equations. In this third type, or this third segment of the chapter, we want to talk about ionic reactions and how we have formation of a precipitate. So what we're essentially doing is we're taking the individual elements or their ions and we're breaking them down and we're looking for formation of a solid. So if you look at this chemical equation here, we have sodium chloride and it's broken down into the ions and we're adding silver nitrate to it. Now in the product side we get sodium nitrate and silver chloride. Notice that silver chloride is the precipitate. So what you do with these type of equations is you look at what is the product that is solid and you work backwards to figure out what made that solid. So we're going to look at how do we get formation of precipitate, and we're going to isolate the ions that essentially create that. Now we're taking this chemical equation and we're breaking it down into ions. And then when we look at the ions, what essentially we're going to do is we're going to cross off the ions that appear on either side. Now what does that mean? Well, here we have a solid, okay? It's unique on the product side, but notice on the reactant side, sodium and sodium on the product side are essentially the same ion, and we call those spectator ions. What we mean is they don't actually participate in the formation of the solid or the precipitate. Notice that with nitrate, it appears in the product side as well as the reactant side. Notice I did not cross off chlorine and silver because they are the ones that help to make the product, which is silver chloride. So we cancel out sodium and nitrate polyatomic ions because they do not participate in the formation of the solid. So the overall reaction is what is left behind. So silver plus chlorine ions together form silver chloride, which is a solid. Okay, here we go. We could have formation of a gas. Now once again, we're going to take the overall equation, we break it down into individual ions, and then we're going to look at where are the spectator ions. So once again, I'm going to look for where do ions repeat themselves. Notice that I have two sodium ions. They appear on either side. Now here is something different. We have CO3 2-, so that's the ion, but we have CO2 gas. Okay, so I'm not going to cross this off because this is going to be something that we probably need for the formation of a gas. Notice that we have two chlorine ions, so I'm going to cross those out because they appear on either side of the chemical equation. But also I have two hydrogen ions. I'm not going to cross that out because it doesn't appear on the either side of the equation. So notice that sodium and chlorine are considered spectator ions. Therefore, the net reaction is what's left. So we have two hydrogen ions plus CO3 2- gives us carbon dioxide and pure water. Okay, so we could have ionic reactions where we're taking acid and a base and we're forming salt and water. So here we have hydrochloric acid and we're combining it with a base, which is sodium hydroxide. That gives us salt in the water. So the net ionic reaction is essentially the hydrochloric acid split into ions along with sodium hydroxide, and that gives us salt and water. We're going to cancel out because these appear on either side of the equation, and sodium our net ionic reaction is essentially hydrogen ion plus hydroxide ion, giving us water. Okay, so with these series of chemical reactions, notice the products have not been written, so you have to be able to determine the product. And with that, you will have to figure out what is the precipitate. I'm going to, for sake of brevity, I'm not going to write out the ionic reaction. I'm just going to eventually write out the net ionic reaction. So I want to do the first one, which is calcium chloride plus sodium sulfate. You're going to have to make sure you know how to take the formula name and create the chemical formula from it. So I'm just going to write out the overall reaction here. So calcium chloride plus sodium sulfate, which is Na2SO4, yields salt plus calcium sulfate. Now, this is not balanced, okay? So once you write down the chemical formulas, you want to make sure you balance it out. And the way I balanced this out is I had to put a 2 in front of sodium chloride. Now, which of these two is going to be a precipitate? Calcium sulfate is. Salt is soluble in water, so hopefully you remember that from previous videos. So this would not be part of the overall reaction. So the way I would draw this is I would put CaSO4 solid as my product. This is going to be part of the overall reaction. And when I look at this, I have calcium and sulfate. So my first ion I'm going to write down is the SO4 2- ion, and it's aqueous, so it is soluble in water. And then look at calcium. Now, you should remember from previous problems, calcium has a 2+ charge. So its overall ionic equation will be Ca2 plus SO4 2- yields CaSO4. Okay, the next equation that we're going to do is sodium chromate and tin 4 nitrate. So I have Na2, and I need to look up my polyatomic ion in order to know what chromate is, plus tin 4. So if it's tin 4, the charge on tin is 4. And nitrate is another polyatomic ion that I need to look up. And then sodium nitrate, NaNO3, plus tin chromate. And this is tin 4 chromate. Now you have to be careful because the charge on chromate is a 2-, and the charge on tin 4, you can't put a 2 and a 4 because they will reduce down to a 1 and a 2 for the subscript. Now this isn't balanced. What I need to do is I need to figure out where's there imbalance. There's a 2 here and there's a understood 1 here. So I could put a 2 here, but I'll tell you right now it's not going to balance because there's a 4 over here for nitrate. So I want to put a 4 in front of sodium nitrate. And in order to balance the sodiums, I'm going to put a 2 here. Now the question is, which of these two are solids? This is my solid. So I want to list tin, CrO4 2, and it's my solid. So I want to look at the ions that contribute to formation of this. So there's tin 4+, and it's aqueous, plus, now I have to be careful, there's a 2 in front of this. So I want to list the 2, and then I want to list the anion, which is CrO4 2 minus aqueous. Okay, so this is my net ionic equation. Okay, I want to do one more with you. This is potassium sulfide and barium chloride. Okay, so potassium sulfide is K2S plus barium chloride yields barium sulfide plus potassium. Okay, this is not balanced. And the good news is, okay, I have a 2 for this chlorine here. If I put a 2 here, this balances the chlorine. Does it balance the potassium? Yes, it does. Okay, so this is overall balanced. Now the question is, which of these 2 is going to produce a solid? KCl is very close to NaCl, so it's not going to be a solid. So barium sulfide is your solid. And then I want to look at the ions that contribute to that. So there's barium, and from the periodic table it's a 2+ charge plus the sulfur or sulfide. Okay, so that is the overall net ionic equation. Okay, so you're going to do the last 3 on your own and be prepared for a video assessment for them.